Okay, so on to number 42. Kind of same idea. This is product rule. So just kind of split it up to get your final answer though. So this is what we would have via the product rule. You're looking for similar things. They both have e to the x. Factor that out. You end up with this. And then my next step is I missed the x. Just factor that guy out as well. And there you are. Quotient rule. Just be careful kind of how you write everything. Hody hi, hidey ho, over ho squared. Implicit differentiation, at least this time, I was happy because they gave us the point. We didn't have to solve for y. You're looking for y prime. So I went ahead and made that a constant multiplier again. Then I multiplied it through to both things. Factor out your y prime, other stuff to the other side. In this case, since you're doing it at a point, the negatives don't really matter that much. Just kind of plug and chug and make sure that you get, you watch your algebra. This will be on non-calculator active. 2 minus 2 was 0. Once I saw it, I had 0 in the denominator. E, non-existent. 45, this is a derivative evaluated at a point. Derivative of sine is cosine. Cosine at pi over 3, that's a 60-degree reference angle. So, hanging out right here, that's your short side, 1/2. This is chain rule. So I rewrote it as 2x to the 1/2, 1/2, and the negative 1/2, that's your outer, your power, multiplied by 2, which is your derivative of your inner. Your 2's cancel, so you have 1 over radical 2x. We're doing this when x is equal to 2. 1 over radical 4, 1/2. This is basically a constant multiplier of 2 and then your chain rule. So 2 is going to stay out front. It's a constant multiplier. Derivative of cosine is negative sine. Keep your inner, multiply by the derivative of the inner. This is going to simplify down into the opposite of sine of x over 2. You're doing the second derivative, so that negative is kind of your constant multiplier hanging out front. Derivative of sine is cosine. Keep your inner, multiply again by 1/2, and that should line up to be e. They love that difference quotient in there, trying to trick you. So this is really just the derivative evaluated at some number. So I'm going to ignore, in this case this is actually nice. What they were trying to do is kind of change things there for you. But really this is what we're focusing on, to take the derivative of tangent of 3x. That's going to be secant squared of 3x. We need to multiply that by the inner derivative, which would be 3. Nice little basic, take the derivative, knock 1 off your power, kick your power out front, so 3/2 x to the 1/2, evaluated at 4, 3/2 times radical 4, 3 over 2 times 2, the answer is 3. This was a lovely implicit differentiation. Kind of just watch those steps. At the end, you got to make sure that you have that negative kind of factored out front if you want your answers to match. I usually start by looking with who has the same thing in the numerator and denominator that I do, and kind of see if I need to factor those negatives out from there. Let's see here. So this was equation of the tangent line. So you had to find the tangent, which was take the derivative, or the slope of the tangent. Take the derivative. Slope ends up being negative 13. Point slope form. Simplify from there. This is still an older version of the test apparently, so they're going to want it in standard form. Very simple derivative, trying to trick you. What they were trying to get you on is whether or not you remembered that the derivative of cotangent is negative. Remember, all of the trig functions that start with a c, all of their derivatives are negative, including the inverse. So that's how I remember it. If it starts with a c, it's going to have a negative in front. Product rule and chain rule. So this guy would have been your u and your v. So your derivative u is x minus 1 quantity squared, so u prime, multiplied by the inner, which ended up just being 1. V is equal to sine of x, so v prime is equal to cosine of x. So just be careful. It really would have mattered if, let's say, that was a 2 hanging out in there, but since there wasn't anything hanging out there, not a huge deal. But this would be one where you have to watch out for that product rule, or I'm sorry, that chain rule as well. Find the slope of the line normal. So they even underlined it for you, so hopefully you picked up on that. Remember, the normal line is the opposite reciprocal, or it's perpendicular to the tangent line. So take the derivative, choose the constant multiplier, natural log of secant of x. So 2 times 1 over secant of x. That would be your outer. Your inner is secant, so multiply that by the derivative. Your secants cancel, so you have twice times tangent of pi over 4. Just remember, you got to take that. You want the normal. So if you went with D, you found the tangent, which is great, but this one was looking for the normal. 56, taking the derivative. Be careful with your powers. I would just suggest you have plenty of room on that test and that multiple choice. Give yourself plenty of room to write things out. Don't try to shortcut things. So your derivative, your power comes out front. This stays the same. That's your new power. You subtracted 1. Derivative of the inner. Kind of clean it up. 2/3. 2 went in the top, 3 went in the bottom. This is the cube root down in the bottom. This guy stayed in the top. You're at x equals 0. Throw in the 0, plug and chug. Take the derivative. If you don't know your rule for this, and this is what we saw earlier, the base was 10. This one was much simpler because there was no chain rule involved. 58, this guy was kind of ugly. There are no nice hints for this one. I took this. My first thing was that I simplified it into this. And then I remembered from when we did exponents, like, well, this guy's e that has a base of e, there's got to be something going on. It's kind of off to the side. I got cut off, but I decided to do, if I have the natural log of x to the 6th equals something, I did, well, this is e to the w. Hold on, let me stop that for a second. Sorry, I didn't write down the thing the right, okay. So it's e natural log x to the 6th. That's equal to something. E, this is an exponential form, so I'm going to put it into log form. So log base e of w equals natural log of x to the 6th. That's natural log of w equals natural log of x to the 6th. So really this whole thing is x to the 6th. Not that I would think this would be something that you would, boom, look at it and see it. The thing that you that they were hoping that you would see is that you have this with a base of e and this with a base of e. This is an actual log property. We spend 10 seconds on it in pre-cal. So this was just a nice, lovely one. Maybe if you would have kind of spun your wheels a little bit and you weren't getting anywhere, you would have thought of that, especially with them giving you these 2 choices at the end. So this is the idea that f is differentiable function. The derivative of f at a matches which of the following? It matches the first and the second. Does not match this one. This is the idea of the derivative at the point A. This is another derivative at the point A. This is not. So the thing is they wanted you to see the limit as x approaches A. So that would not be equivalent to the top 2. This guy was lovely. I tried it quotient rule one time and it drove me crazy, so I went ahead and just switched that negative, or that bottom one, into a negative power. And carefully, this is my u, carefully took the derivative, my v, carefully took the derivative, and I just plugged it in. So this was this times this is my first one. And as I went through, positive went in the top, and I switched it back into radical form. The negative went to the bottom, and I went ahead and simplified that guy out because I knew I was going to have to evaluate at x equals 0. Same with the second one. Ironically, this all cleans up quite nicely to just kind of be this. And the very nice thing is, in the top you have 2x, which was 2 times 0, which made that whole thing 0. So it was nice because in the end, you really just had to look at the derivative in the front. This is inverse with chain rule. So here's your inverse, here's your chain rule, clean it up. Product rule. So just be careful how you write it. Anything too crazy. This was my u and my v stuff over here. It's kind of plugged and chugged. Did we just do this one? There we go. Take the derivative. So I rewrote it. The only thing I really changed was this 1 over x, and I made it into x to the negative 1. Put your numbers in. Good to go. This is just basically take the derivative. This is another product rule. Be careful with how you write everything. I'm sorry, this is not product rule, it's chain rule. So your outer is your power, so you can do that first. Your first inner is cosine. That's negative sine of x cubed. And your last inner is x cubed, so 3x squared. A nice little, just take the derivative, shouldn't be anything too crazy. So your derivative is the opposite of sine at 2x times 2. Go ahead and you're evaluating this at pi over 4, so when you have pi over 4 and that simplifies to pi over 2, and just throw it into the equation. That's a little bit more work, so the point on the graph, and this is my graph, the tangent line is parallel to this line, so you needed to solve for what your slope was on this, and ended up being 1/2. Take your derivative of this guy, which ended up being x, set that equal, your derivative equal to what it wants, so that happens at x equals 1/2. So you need to know it says points, you need to know your corresponding y. Well, plug and chug it back into here. 1/2 times 1/2 squared. 1/2 squared is 1/4, so 1/8. So there's your final coordinate. This guy was lovely. It's implicit differentiation twice. The trick is you're going to implicitly do your differentiation one time, and you know your point. So plug in and find out what your first derivative is at that point, and it ends up being negative 4/3. Take your second derivative, leave it kind of in its bare bones state. This is your x, this is your y, this is your y prime. Put those numbers in. This was 3 minus 16 over 3. I made it into 9/3, so I could kind of do my fractions a little bit easier and simplify from there. 68, that was e to the 2x over 2x. Hody hi, hidey ho over ho squared. Got to factor out. This guy had 2 and ex kind of hanging out, and then you would cancel top and bottom. Take the derivative, set it equal to 3. This is calculator active, so you need your calculator. Looking at those answers, you probably should have assumed you need your calculator. Derivative set equal to 3. Graph it, find your point of intersection. Implicit differentiation when x is equal to 2. So you had to solve for y again. Y was equal to 3. Take your derivative, put your x's and your y's in. Just make sure when there is a y with implicit differentiation, you better see a y prime. Instantaneous rate of change, it's asking you to find the slope at 2. Hody hi, hidey ho, put 2 in, simplify. Take the derivative, so this is going to be an example of the chain rule. Kind of twice. Your outer is sine, and then you have another outer of e, and then your final inner would be negative x. So derivative of sine would be cosine. E to the negative x, your next inner is e to the negative x, and then you take the derivative of that, which is your negative 1. Just kind of clean it up, move it around, see which one he matches. 73, an equation for the line tangent. So take your derivative, put in your 0, 1. Shouldn't be anything too terrible. Later test, because now you're in slope-intercept form. 74, same thing. So this is an example of the chain rule. Just make sure you're paying attention to all those things. This is secant squared. Secant is related to cosine, so you're really finding cosine. Cosine at pi over 3 is equal to 1/2. The reciprocal would be 2. Make sure you're squaring that. It's probably the easiest mistake to make. So you want to know, when do these two functions have tangent lines that are parallel? So take their derivative, set them equal to each other, find their point of intersection. So this is the functions, the absolute value functions, which is true. Absolute value is continuous. It is not differentiable because it has a corner hanging out at x equals 0. They would have had this as like x equals 1, then yeah, it would have worked. But it's x equals 0 and there's a corner hanging out there. Absolute minimum sure does. Last but not least, plug and chug. So this would have been, I put in y1, y2, because there's no way to solve that any other way. You need to evaluate that function to find your y value, and put it into point-slope form and convert it into slope-intercept form.